In this video, we are going to explore the Python Global Interpreter Lock, also known as the GIL. We will discuss what it is and how it impacts Python programs. The Global Interpreter Lock, or GIL, is essentially a lock that allows only one thread to hold control of the Python interpreter at any given time. Consider it as a gatekeeper, ensuring that only one thread can execute Python bytecode at once. This means that even if you have a multi-core processor, only one thread can be actively running Python code. All other threads will have to wait for their turn. So, in short, the GIL is a mutex or lock that protects access to Python objects. It prevents multiple threads from executing Python bytecode simultaneously. Now, you might wonder, why does Python have this global interpreter lock? There are a couple of reasons. First, it simplifies memory management. Python uses reference counting for memory management, and the GIL protects against race conditions that could occur if multiple threads tried to modify object reference counts simultaneously. Second, the GIL was introduced early in Python's development to easily integrate with C extensions, which were not inherently thread-safe. The GIL ensures that these extensions can safely access Python objects without causing crashes or data corruption. Finally, it protects the reference counting system. The GIL significantly impacts multi-threading in Python. Specifically for CPU-bound tasks, where the code spends more time performing computations than waiting for external operations, multi-threading doesn't provide the performance benefits you might expect. Since only one thread can execute Python code at a time, the other threads end up waiting for their turn, which limits parallelism. Moreover, there is an overhead associated with thread switching, which can further reduce performance. Because of these limitations, multi-core processors cannot be fully utilized when using threads for CPU-bound tasks. Thus, for CPU-bound tasks, threads do not yield the performance increase. Despite the limitations posed by the GIL, there are several workarounds to achieve parallelism in Python. One common approach is to use multiprocessing instead of multi-threading for CPU-bound tasks. Multiprocessing involves creating multiple separate processes, each with its own Python interpreter and memory space, effectively bypassing the GIL. For input-output bound concurrent operations, you can leverage async I/O, which allows a single thread to handle multiple concurrent tasks efficiently. Additionally, you can use C extensions that release the GIL during computation, allowing other threads to run in parallel. Finally, you might also consider alternative Python implementations such as PyPy, which employs a different approach to memory management and concurrency, and may not be subject to the same GIL limitations. When deciding between threads and processes in Python, it's important to consider the nature of the task at hand. Threads are typically well-suited for input-output bound tasks, where the program spends time waiting for external operations such as network requests or file access. Threads are also beneficial when shared memory access is advantageous, as threads share the same memory space. Processes, on the other hand, excel in CPU-bound tasks, where the program spends most of its time performing computations. Processes also provide better isolation compared to threads, as each process has its own memory space. Thus, to summarize, the GIL prevents Python threads from executing Python bytecode in parallel, but doesn't affect input-output operations. For CPU-intensive tasks, use multiprocessing to bypass the GIL and utilize multiple cores. For input-output bound tasks, threading or async I/O can provide concurrency benefits despite the GIL. Understanding the GIL is crucial for writing efficient concurrent Python code. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.